anecdotal evidence, and some preliminary studies suggest that eclipses can indeed lead to noteworthy changes in animal behavior. This paper synthesizes the available information, highlights notable examples, and discusses potential mechanisms behind these effects. Total solar eclipses occur when the moon passes between the Earth and the Sun, temporarily casting a shadow on the Earth's surface. This phenomenon, with its sudden darkness and altered environmental conditions, has the potential to impact various aspects of the natural world. While most eclipse research has focused on atmospheric and astronomical effects, there is growing interest in understanding how total solar eclipses influence animal behavior. Total eclipse effects on animal behavior. Diurnal animals' behavior. Some bird species exhibit altered behavior during a solar eclipse. For instance, birds that are typically active during daylight hours may become quieter or return to their nests. Nocturnal animals, such as owls and bats, may become more active during an eclipse, as they perceive the event as dusk or twilight, prompting hunting or foraging behavior. Aquatic animals are marine life. Underwater creatures may experience disruptions in their daily routines due to the sudden change in light levels, affecting predator-prey dynamics and migration patterns. Coral reefs are coral polyps, sensitive to light, may retract their tentacles during an eclipse, offering a unique opportunity for researchers to study their response to reduced light. In insects, fireflies, these luminescent insects might exhibit unusual flashing patterns during a solar eclipse, possibly related to changes in their circadian rhythms. Bee foraging activity may decrease during an eclipse, as they may perceive the event as early evening, returning to their hives earlier. Domestic animals like dogs and cats may become disoriented or anxious during an eclipse, displaying unusual behavior, such as howling or seeking shelter. Wildlife. Some wild mammals, like deer and rodents, might alter their feeding and movement patterns temporarily. Mechanisms behind behavioral changes. The exact mechanisms triggering these behavioral changes in animals during total solar eclipses are not yet fully understood. Potential factors include altered light and temperature conditions, changes in perceived time of day, and the animal's internal circadian rhythms. Animal confusion. During a solar eclipse, some animals exhibit unusual behavior. Nocturnal animals like owls and bats may become active, thinking that night has fallen prematurely due to the sudden darkness caused by the eclipse. Cicada choruses. Cicadas, known for their loud buzzing sounds, tend to go silent during a total solar eclipse. This phenomenon has been observed, and scientists believe it's their response to the abrupt darkness, as they mistake it for nighttime. Bird roosting. Birds, especially those that are active during the day, may return to their roosts during a solar eclipse, thinking that dusk is approaching. This behavior is a temporary pause in their daily activities. Aquatic activity. Aquatic animals like fish and turtles may behave differently during an eclipse. Fish might rise to the surface, and turtles may come ashore, possibly due to the darkened sky and cooler temperatures that make them feel safer. Additionally, insects, such as bees, may temporarily stop their pollination activities. These fascinating observations highlight how the natural world responds to the unique environmental conditions created by a solar eclipse. In conclusion of this video, while empirical data on the effects of total solar eclipses on animal behavior remain limited, anecdotal evidence and preliminary studies suggest that these celestial events can indeed influence various species. Understanding these effects is not only fascinating from a biological perspective but also provides valuable insights into how animals perceive and respond to environmental changes. Future research efforts should aim to document and analyze these behaviors more comprehensively, shedding light on this intriguing aspect of eclipse phenomena. Subscribe, share, link and write comments on our research.